Hi guys, we got a couple questions yesterday, so I thought I'd go over a few of them for you. First one was going over domain and range. Now, everybody seems to struggle with this. This is an ongoing thing, and every year. Domain is always the horizontal. Range is always the vertical. So what I got to do is decide where the vertical values are possible and where the horizontal ones are possible. If you look at this graph, solid dot, that means it's included. Included. Hollow not. Included. So that's going to matter for as far as my symbols go. My greater than, less than, that's not included. Greater than equal to, less than equal to, that is included. So for this first graph, my domain, I'm just going to use a D, is X. So I do that. The lower end is a 1, and it's included. And then I have X less than or equal to, less than, because it's hollow, 8. And that's it. Domain. Range. It's vertical, so it's Y. And that's what this part states. I'm talking about X, talking about Y. Now what's it doing? It's going from 2 to 7, but 7's not included. So 2 is less than or equal to Y, 2 is less than 7. And that's, I always do that. This way for domain, this way for range. Now, leading into some other stuff, down here I have independent and dependent written. Independent is always the domain, and it's always the horizontal. Dependent is always the vertical, and it's always the range. So, that was that one. A couple of little other examples here. This question, I look at it, my domain, because of these arrows on the ends, it means it goes on and on and on forever. So it's going to keep getting wider and wider and wider, and there's no limit on X. So X can be any real number. No limit. Range, on the other hand, has a limit. Y, all my Y values are below 3. That's not a negative 3, it's just 3. So Y has to be less than or equal to 3. Because they're all below that line. Alright? So it's that one, which may be helpful for your assignment. That particular question. Now, here. This thing. I gotta go based on the dots. And because it's discrete, and it's just dots, I just have to write the dots. This is X, this is Y. So for my domain, which is my X, I just look at that. I've got a 1, a 3, a 4, and a 7. 1, 3, 4, 7. Range, well, it's my Y values. So I get a 2, a 3, a 4, and a 6. 2, 3, 4, 6. Done. So when it's set up like this, where it's just dots, I just write the values. The possible X values, the possible Y values. Okay, so that's domain and range. Hopefully that's helpful. Independent, dependent. I've mentioned this a couple times already. Independent is always the horizontal. And what else can I tell you about the independent? It's more, you have more control over. Is the best way to describe it. Dependent depends on the independent. So whenever I have a word problem, my y value depends on x. My distance depends on time. So if I have distance depending on time, distance is dependent, time is independent. Yeah, cost depending on how much I buy. Well, the cost is the dependent. How much I buy is independent because I have control of that. Okay? Now, the last part, discrete and continuous. Discrete, dots. People, because anything I can't have half of, bottles, apples, markers. When I'm graphing it, I'm not going to graph and say, well, I have 2.5 markers. So based on that situation, I have what's called discrete data. I don't connect the dots after I graph it. Continuous, time, continuous, weight, height, tides, all these things are continuous. Now, somebody did ask the question, well, what if one is discrete and one is continuous? As soon as one of my variables, so sometimes the dependent can be discrete and the independent continuous. But as soon as one of the two variables is discrete, then the graph is discrete and I can't connect the dots. And I hope that's helpful. Get a video 5.7 example 4 coming soon. All right, bye.